Hi everyone, good evening once again. Hope you guys are doing great and had a gala time in the weekend. Let's start our discussion. As part of our sessions here, we've been discussing about how analytics is implemented in the space of HR analytics. This is basically a solution that we are trying to develop using data as the ingredient. From a HR perspective, the day-to-day job looks at a huge amount of data from an organization perspective, organization goals perspective, individual employees perspective, a team, group of employees perspective, their production perspective, compensation perspective, hiring perspective. There's a lot of data that is getting generated. And all this data is recorded in a centralized repository. And there are readily available end-to-end solutions for these repositories. We call that as HRIS or HRMS systems, where we'll have a lot of reporting tools and a lot of readily available dashboards, which gives the management or HR department a lot of insights about all the aspects that are required for decision making in the space of HR or resource management, or you can say workforce analytics. Now, in the previous sessions, I have specifically talked about how the data can be utilized for developing various reports. But in order to develop those reports, the data has to be cleaned and appropriately arranged. And for that, we do pre-processing or cleaning or organizing of the data. We call this as data preparation, or we also call it as data pre-processing. As part of the steps, we basically do a lot of cleaning, filling up of missing data, trying to organize the data from one form to another form, right? All these are high-level steps that we perform. And this is to ensure that we have data arranged in a proper format and an organized fashion. And that organized fashion is nothing but a table, collection of rows and columns. This is the organizing right, that we need to do before we actually implement mathematical or statistical based logics on the data. The tool which is broadly utilized in the industry right now, which is very popular, is Python. But there are various other readily available tools which can be used for data processing. And we've been using this Python because of its flexibility, because of its capability in the space of machine learning and AI. Once the data pre-processing is done using Python, we will use Python libraries, right? These libraries are readily available codes which help us to do all the right cleaning or pre-processing that we need to do. You don't have to write the logic from scratch. The code is already available and we should utilize that code. Right? That's the logic that we have to think about when we're talking about libraries, Python programming language. Next. As part of the analytics implementations, we also spoke about the 4 stages of analytics, which start from generating reports and summarizing the past. This is basically called as descriptive analytics. And these systems that we were talking about, the readily available end-to-end softwares, the ERP packages that we speak about, they contain HRMS and HRIS kind of systems. They contain a lot of readily available reports, report templates, which can be used for generating the right dashboards, the visualizations and all that, for generating descriptions on the data. That is nothing but descriptive analytics. And because you're a subject matter expert with your experience in this domain, you'll also be able to diagnose the problem, investigate and identify the factors which are influencing an incident or an event. Diagnostic analytics. Then we talk about predictive analytics. This is what we are trying to learn as part of this applications of analytics and HR domain sessions. How we can become future tellers, right? Oracles, where we try to predict the future. But when you're trying to do that, we utilize data, right, as the key ingredient. And we look into the past data and try to define some kind of a hidden pattern which can explain us what could happen in the future as well. And to implement this, we are using the mathematical logics. We'll try to define the business case in a mathematical notation. And we try to identify the function. The function is nothing but, this function that we are talking about is nothing but the relationship between the factors, and then these are the factors on the output. These are the various factors which cause the event. And with respect to these features, the output is getting affected. So how is it getting affected is what we are trying to define using this function. And as part of this discussion, we talked about regression cases. Regression techniques, we call them as regression techniques, which simply use some mathematical, predefined mathematical equations like y is equals to mx plus c kind of a equation. Y is equals to mx plus c is a straight line equation. Right? Y is equals to mx plus c. It's a straight line equation. If you remember your 10th grade, right, primary school education, 9th grade, 10th grade, that is when we have seen the equations, right, polynomial equations and equation of a straight line. And we used to draw these lines in a graph sheet, right? These are green color, black color, pink color, right, blue color sheets, the grids. They'll be like grids. Within that, we used to have lines like this, right? And we used to draw lines, straight lines, using a different color like this. So this is exactly what we are trying to do here. We are trying to draw a straight line in a space, x and y axis space. That's called as linear regression. Now, linear regression is speaking about constant relationship, or we can say consistent relationship, constant or consistent relationship, where we are saying that if x is changed by, let's say, 1 unit or 2 units or 3 units, where x is changing by some percentage, then y gets affected by some constant effect. That is represented here. So if you look at y is equals to mx plus c, we are saying that if x is not there, y is c. If x is equals to 0, y is c. But if x is included in the equation, if I bring in a factor which is influencing y, then if x is increased by 1 unit, then we are saying that Y is getting affected by M units. Mx plus C. So M plus Mx plus C, Mx plus C is this. So Y new is M plus Y. So if X is increased by 1 unit, Y is getting increased by M units. This M is nothing but the rate of change. M is slope, and we've also discussed that this is nothing but rate of change. This is something that we discussed as part of linear regression, where we are trying to predict a value on this straight line for any given value of X. And this value can be anywhere on this line, including decimals, right? So when you're trying to map it, the Y could be in decimals as well. This is about linear regression technique. So let me erase this, and post this linear regression concept, we discussed about logistic regression, which is another variant of regression technique. And here we try to predict output variable, which is binary case. Right? We were only trying to address binary case. So if linear regression says what should be the increment for an employee, given the various factors, what can we predict for the increment in the salary, where Y could be in decimals here, right? That is linear regression case. In logistic regression case, we will try and predict whether an employee will resign or not. So binary case, resign or not. And we understood that in logistic regression case, we will only have value which is lying between 0 to 1. Because logistic regression will give us the probability of the event, where probability will always lie between 0. And this is what we discussed. And this S curve, or we also call it as sigmoid curve. Right? This is also called as sigmoid curve, will always lie between 0 to 1. We discussed about employee performance, if you remember. Right? Performance of an employee in a QC team, quality control team. And using this logic, we also try to streamline the time duration that each employee, the QC engineer, should spend reviewing a product, a circuit. Right? That is what we discussed as part of our logistic regression case. Now let us also talk about a little variant of this prediction case under predictive analytics itself. We'll talk about a different use case altogether. And once we know what will be the output, as part of the stages of analytics, we will do prescriptive analytics. Right? Now let us talk about the use case here. Let's say there is an organization, X, Y, Z. And of late, this organization has seen a lot of iteration. A lot of people are resigning, right? Resignations. Now, when we speak about this organization's challenge, HR people will become very critical, because see, always hiring new people is a very costlier effort right? From all the perspectives, the training perspectives, the team overall organization's productivity perspective, the individual production perspective, right? Everything is costly whenever you're bringing in new people. So from an HR perspective, obviously we want to ensure that an existing employee is retained for as long duration as possible, right? That will ensure that the continuity in the business happens, the production happens. Of course, new energies, new ideas have to come in, new members have to come into the team, but we also want to ensure that the best performers in the organizations are always retained. Now, what we do, we may use logistic regression. This is something that we have used or learned, right? Binary prediction model. So you might use logistic regression and try to say whether an employee will resign or stay back, or do not resign, you can say. Okay, this is your prediction you want to do, resign or not. It's a binary case, right? If a person is resigning, you will say 1. If the person is not resigning, then you will say 0. Now we can use this prediction model right? And then you predict whether a given employee would resign or not, given multiple factors, the salary, the increment, the manager, the number of working hours, the travel time that the employee takes from home to office, whether working from home option is given or not, especially in COVID times, right? Medical benefits are given or not, shares are given or not, right? So a lot of things come into the picture, which might motivate an individual to consider for resignation. So logistic regression is a very, very good tool to upfront identify who's that employee who might resign, right? If as a HR, if I know that a specific person is going to resign, let's say there is a 1,000-member team. Out of this, when we are doing the prediction model here, the logistic regression, we found that there are at least 100 people who are about to resign. The logistic regression says that these are the people who will resign. Did they resign? Did they apply for resignation? Not yet. We are upfront predict. Now, if you know as a HR personnel, if you know that a specific person is going to resign, then obviously you will try to counsel that employee, right? You conduct some kind of counseling sessions, one-to-one sessions, and ensure that that particular employee, right, is retained back. So you might want to understand what are the challenges that the employee is facing, why the employee is considering the resignation as an option, right? So on and so forth. Right? So prediction can help address right, iteration for some extent. But let's assume that out of these 100 people, HR personnel goes and tries to counsel each and right, every person in this group, 100 people. Now, when HR is trying to connect with this employee one-to-one, probably the model, the logistic regression model is predicting that they are right going to resign, but probably the employee did not even had a thought, right? But when this one-to-one meeting happened, that's when a lot of things stirred up. Maybe after that, the employee is trying to right started to think about resignation. Prior to that, the person might not even had the thought, right? That could be the case. Now, an employee might be resigning after 6 months, after 1 year, or maybe next month. We don't know. The logistic regression model that we are using here is trying to predict whether an employee is going to resign or not. When does that employee resign is something that the prediction model doesn't tell us. Obviously, that's not what logistic regression is built to do. It's only about to tell whether it is resigned or not, whether the person is going to resign or not. That's all. Right? So now the challenge comes in. So how do we address this? How do I use the information much more appropriately, or can I define something which can actually refine the approach to the employees? So ultimately, our objective is to maintain the iteration, right? So I need to retain the good talent. So once the resignation is applied, that's when the HR people try to counsel the employee, try to give some kind of options to ensure that the employee is retained. But if I can upfront know, then it will definitely help me to retain that employee in a better rate, at a better rate. But to do that, I need to also know when the employee is going to resign. So your prediction models, right? The prediction models will tell whether an employee is going to resign or not. But if, as a HR person, if you can know when, right, that is going to help the HR personnel to plan accordingly to counsel that employee. I don't want to touch this person immediately. I want to ensure that this person is stayed for a longer duration. Then probably I'll set a long-term goals for these people, 6 months and 1 year. The overall retain factor will increase automatically if I do this, right? So when is an important question which we need to understand, and that's what survival analytics is on. Though the terminology looks like more of a healthcare related terminology, but survival is a generic term that we need to consider here. There are many applications, many use cases of survival analytics. Right? We will talk about some of them. We'll also see how the survival analysis is implemented, what are the components that we basically use. And we will discuss Kaplan-Meier survival function, which predicts event, non-parametric values. And this is the most popular model in the survival analysis concept. We do have semi-parametric and parametric models as well, but non-parametric is very heavily used in the industry. The survival analysis is also got another name, right? Set of names, in fact. Duration analysis, transition analysis, failure time analysis, or time to event analysis. So in all these cases, we are trying to analyze the duration, right? We're trying to analyze the duration. Right? So if the employee is joined the organization, let's say in 2015, assume, right? An employee who stayed long enough to see various ups and downs of the organization. Oops, sorry. 2022, let's talk about current date, not 10 years. So we have an employee who's from 2015 till date. Now this person is planning to resign. Okay. So you might want to know, will this employee is going to resign next month or after 2 months or 3 months, right? What is that? Now to talk about this duration, we look at historical data of all the employees who have resigned or who have stayed back, and then we will try to generalize the behavior for future perspective as well. Okay. Now here the event is important. We are analyzing the duration. This is the duration. And from the historical data, we look at the events that were occurring at different durations in the study period. This is the total duration that we are analyzing the historical data for. Event. In our case, we are talking about employee resigning from the job. Event is resignation, right? We're talking about that only, right? Whether the person is resigning or staying back, not resigning. That is the event, specifically this. Now we are talking about time to event. In this duration, if the employee started here, then will the employee resign here or here or here or here? Where does the employee resign? Right? So that is something that we are looking into. There are some of the use cases you can see. The survival analytics specifically is coming from medical field, healthcare department, healthcare domain. But it is applied in various domains: finance, life sciences, economics, edtech, everywhere. In the HR, we are talking about a simple use case, whether an employee will resign the job or not. Next. When we talk about this scenario, right, employee iteration, there may be a lot of cases where censored data occurs. The first thing, okay, before we study anything further about the survival analytics, you will always see that the survival analytics distribution is not normal. It is abnormal. It's not like a regular scenario, right? We're not talking about events. We're trying to analyze the duration of the events. So the data should be focused more on the duration and not the events. And that's the reason why we say this is not normal. This is something which is, right, above normal. Now, when you're talking about this above normal data or abnormal data, it's called as right skewed. Now, if you don't understand that's the terminology, that is absolutely fine. It's like what happens is when the duration of analysis begins, we'll have 100% of the data. But as the duration goes by, the data will get reduced because some people will resign, some people will retain, but some people will resign, right? So this is the study. Now, there are cases where when you are doing this study, a biggest problem of missing data happens. Missing data might occur. This missing data will cause a lot of analysis gaps in this study, survival analysis study. And this missing data is called as censored data. So the scenario is the events that we are tracking, right? We will be tracking the events with respect to subjects. In our example, subject is an employee. So we will track employees until the event happens or we lose them from the sample. So if this is the duration, we will track each and every employee on what they are behaving here with respect to the event, of course, resigned or not resigned, in the given duration. So probably I'll set a target of 18 months, 1.5 years, or maybe let's talk about 12 months. Let's put it to 1 year. So in 1 year, how many people are resigning at what rate? Some people will resign early, some people will resign late, some people will not resign at all. So we are tracking the behavior of these employees with respect to the event. Now, we will also have data which is lost from the study. So in this case, we call that as the data as censored data. Okay. So time in employment until attrition. We want to see how long the subject is staying in the sample. Now, when we are doing this analysis, we will be interested in finding something called as hazard rates. hazard rates, all right, is nothing but risk of failure, which is nothing but chance. Risk of failure, right? Chance of the event occurring or event not occurring. And when we talk about chance, it's nothing but probability. Right? Nothing but probability. Some of the examples. Time from starting subscription to churning to of a telephone subscriber. So if I take a mobile connection, I'll purchase a SIM. Probably I'm taking a SIM of Airtel or any of the connections. Example one. Telecommunication one, right? I'm purchasing a SIM from them, and then I will do porting. From one network to another network, I will change the subscriber. I mean the operator, right? So probably from Airtel, I'll move to Idea. From Idea, I'll move to Jio, right? So on and so forth. Time from issue of credit card to first default payment. Now we are using credit cards, right? For a long time, we've been using credit cards. But somewhere at some point, you may default, right? I mean, I'm not saying that you willfully default, but there may be a case where you might forget. So if you do that, if you are doing such an incident, probably in the first year of taking credit card, or maybe after 10 years, you're doing it somewhere, you're doing it, right? So the time duration from you get the credit card to your first duration, first default transaction, a defaulting case. That's the duration that we are analyzing. Right? That's the behavior we need to try and track. This is one customer example. We may have many such customers, and we are trying to generalize the behavior. So there are other use cases also from finance and from insurance segment. Sales segment also is there. Now, what we are trying to understand is, look at the natural patterns for the entire data. Don't look at just one record. We need to look at multiple records and try to understand in general what are the kind of patterns the data has. Right? And we need to identify at what time point, timestamp, in that duration that we are analyzing, the survival rates might fall down. Remember, survival rate is nothing but the chance or probability. So you are looking at the probability at, the fall in the probability at a specific duration. And we're trying to analyze why such fall. And we try to compare this survival curves that we are going to create, right? This survival rates that we are analyzing, they're generated in terms of visual representations. We will try to compare those visual representations with respect to demographic groups or customer segments or sales channels, some categorical, categories that we take. And then we try to group the data and then compare these groups. This will help us to identify the key factors which are actually affecting the probability, right? So let us look into this. Yeah, before I proceed, we need to discuss about the censoring case. The censoring can be very well understood using data with respect to life sciences, because survival analytics is defined or derived from life sciences healthcare domain. But I would want to explain this in both the ways, from life sciences scenario as well as from the HR perspective. I'll start with life sciences because it is simple use case. You'll also be able to correlate. A very, very generic example I'll try and give. So let's say COVID, we'll consider COVID case. Now for COVID, we don't have a proper treatment, right? Only vaccination is available. And in fact, when COVID struck, we did not even had this vaccination. But now vaccinations are available. Let's assume that the vaccinations are being studied. So doctors were doing various kind of human experiments, right? We also call it as clinical trials. Before the medicine can be released, it has to be tested on humans, right? So we talk about human trials. So here, assume we have 10 volunteers joining that particular study. They trust the doctor, and right, they started taking the medicines. Now, doctor assume, right, this is just a case, assume the doctor was doing the study for 16 months. It starts from 0, of course, but it ends still at the 16th month. That was the total duration that doctor decided to analyze the patients who are taking this particular treatment of some kind of a medication. So month on month, the review will also be done to check how the patients are doing. Okay, that's how the human trials are actually done. So here, the event is something you need to understand, okay? With respect to COVID's case, the event is either the patient is dying or completely getting cured. Either the patient dies or completely gets cured. This is our event. Okay. Now we are analyzing the subjects, volunteers who are taking part in this clinical trial, the human trials example. If I have to bring the point, let's say these 10 volunteers, they started taking the medications that the doctor is giving, and month on month, the doctor is doing a study. Now, at the end of the first month, we see that this subject has died. So when the analysis has started, we had 100% data. So whatever the subjects that we have, 10 subjects, so this is full data set that we have, it's 100%. But the end of the first month, 1% died. So how many people left out? 9 subjects out of 10. So that means 90% survival chance is there if the patients are given this kind of a treatment, right, for COVID-19 case. Then there is a 90% chance that the patients will survive at least 1 month. Right? That's the statement that we'll have to make. But here we are trying to understand censoring, right? Now let's say this particular subject was not interested in study, so he dropped out. So what happens? Because that particular patient is not having, or not taking the treatment, is not present in this particular study, all this data will be missed, right? We'll not be able to know what happened to that particular patient. So this is missing data. We call this as censored data. Another case, subject 7 has died because of accident, right? So here also the data is missing. This is also censored data. Now, one thing you need to understand is this an event that we are trying to analyze here? No, this is not the event that we are actually looking out for. Okay, so we consider that the event did not happen, but we are not also getting any data. Hence, this is missing data that we see. Okay, so this is censored data. There are different types of censoring also, right? Censored, left censored, interval censored, and all that. But censored data means missing data. Now, if I have to put this from a HR team's perspective, now let's say you are closely watching 10 employees in your organization, potential customers. I mean, out of 1,000 employees, you identified that 100 people are going to resign using logistic regression. Let's assume that out of 100, 10 people are being closely monitored by randomly picking them out of 100. So HR team, right, we are now looking at these 10 subjects very closely. What is that they are doing month on month? Now, let's say at the end of the first month, this particular employee has filed a resignation. He resigned. That means event has occurred. This subject probably had to move to a different branch, right? Or maybe different project. So the HR person who's trying to analyze this particular person, this is a particular employee in that particular, let's say, office, would not be able to do it anymore because the cost center has changed. The employee is now reporting to a different manager, different HR and all that. So this particular HR who is doing the analysis will not have any relevant data with respect to this subject. And we know that this employee has not resigned till at least their date. Right? So this is called as censor data. All right. Now this employee, another case, has not resigned, but probably the employee has, the organization, employer has fired him because of COVID cases, right? A lot of employees lost their jobs because of COVID. So at this right scenario, that could happen. The employee was sent out, removed, terminated, you can say. The employee termination is happening, but that is not from an employee perspective. Employee did not apply for resignation. So event happened, but not what we are actually intending to, right, study. Right. So from here on, the employee's data will not be available, right? Though the event did not happen. So this is also censored data. Right. So this is how we see missing data is nothing but censored data here. And one thing you need to understand is at the beginning of the study, we will have 100% data. And as the duration goes by, the amount of data that we are seeing is getting reduced. And we'll only talk about the duration of our right, analysis, whatever the duration that we are studying the data for. We speak only for that duration. All right. So that is about the right censored scenario. And we will get something like this. Survival plot. And we're also looking at whether an increment is motivating an employee to stay back or resign quicker. Right? So we have two segments, people who did get increment, people who did not get increment. Right? Promo is nothing but promotion. You can build it as. So increment and no increment. Right? And you can see in the graph, people who did not receive the increment, did not receive the promotion, they were the people who are resigning a lot. So the line is coming down drastically. That means more number of people have resigned. Whereas this one is more like a linear line, a straight line. As the duration passes by, yeah, people tend to, right, keen on resigning one organization to find a new opportunity, just the sake of getting new exposures and all that. So these kind of cases are more linear, but this one is, you can see it is coming down drastically at a very rapid pace. And that too, especially after you get the promotions announced, the increments announced. People who did not receive the increments, they immediately try to jump for different companies. All right, so that is the Kaplan meier survival plot. And we are going to try and do this on our data. And yeah, let's try and do this here on Spider. Now, in order to implement the survival analytics in Python language, Python programming language, we need a specific functionality. Kaplan-Meier fitter. Remember, we are doing non-parametric Kaplan-Meier survival analysis only. To implement that, we are going to call this particular function using a library called lifelines. Now, this lifelines package, right, has to be downloaded, and it can be downloaded using this command, and it's a one-time activity. So from a centralized repository, which is maintained by the community, Python index, Python programming index. In this, we'll have a folder called lifelines. So we are trying to get this particular content into the computer by using this command. Okay, and then we proceed with data loading. In our last exercise, we've discussed about how the data can be loaded. Okay, 1 second. I see the data not being available properly. The folder name has changed. Okay, this is the data. Let me change the data name here in the code. Okay, I just have to add this number. That's the file name I have. So this is the, this is the data set. Duration in months and the attrition. And this is the increment, whether it was given or not. Attrit means, yes, the employee has resigned at 3rd month. This employee has resigned after 21 months after their joining. And these zeros means the employees did not resign. Okay, they are staying back. So we want to try and analyze this particular data. And yeah, let's not use all this, not required. Now, if you look at the columns, you have duration in months, attrit, and increment, right? So I'm going to change these names to a simple names. I'll talk about this as spell. This is the duration, event, and then we also have increment, right? So we are just changing those names to a simple one-word sentences. And then I'm bringing in this library. From lifelines, import Kaplan-Meier fitter. I'll call this function. I'm giving a short name called KMF for this Kaplan-Meier fitter. You can see the documentation. It says class for fitting the Kaplan-Meier estimator for the survival function. As I explained, survival function is nothing but cumulative distribution function. That's nothing but probability. Right? In our case, less probability is not good. Right? We need to see a curve which is going like this, right? Or which is going like this. It should not go like this. This means desperate. More and more people are resigning. This is not good. Okay, so we will try and look into the survival function also, define the function. Then we are trying to fit the data to this function. Spell is nothing but the duration, and the event is being called as event itself, whether the employee is resigned or not resigned. So I'm calling it as event. And when I do this, it implements the Kaplan-Meier exercise on, or the model on this data. We can look at the plot. KMF.plot will give us the visual representation of the entire data set. And you can see at the beginning of the phase, right, at the beginning of any employee's career or with respect to an association, to an organization, as soon as this join, right, as soon as they join, At the immediate stage, there will be huge right, chance of iteration. But if they stay back at that duration, then the attrition will be linear. And at a middle age, right, after 5 years, you will see again, right, some kind of a drastic decrease. And after that, if the employees are staying back for more than 5 years, then generally you see people staying back till 10 years, 12 years, or maybe 15 years also, some cases. So this is where you will see the line becomes a little straighter. That means the amount of people resigning will be less in their mid-age segment. Initially, there will be a good size of right, iterations. At around 5 years, you will see a good amount of iteration, right? Somewhere around 5 to 6, 7 years. But after that, it becomes a little right, straighter. And then again, around 15 years, you'll see the change. And people who stay back for 20 or more than 20, they very rarely right, move away from the companies. And yeah, some people might resign or retire in the organization itself. So this is a generic flow. Now, what is the effect of increment being not given to the employees? Right? Whether the increment was given or not given. If this is the scenario, then what? So what we are trying to do here is we are grouping the data into 2 parts. You can see 1 and 0. 1 means the people who got the increment. 0 means the people who did not get the increment. Right? So we are trying to split the data. If you look into this data, I have grouped like this. If I click on the increment part, you will see all zeros here. And we know how many zeros are there? 1495 zeros are there. Out of 3,343 records to be exact, we have almost half of the data as 0. I'm staying back, right? And in this case, in this case, we are talking about increment, my bad, not the event. So these are the people who did not get the increment. Now, what is happening only to this segment, right? This group. And similarly, I will try and understand what is happening with this group who got the increment. If increment is equals to 1, that means these people have got the increment. Right? So let us try and apply this. We are only taking the records from the increment part where the increment is equals to 1 for spell as well as the event. And I'm labeling that as 1 in the visualization. And I'm calling this as AX. These are the people who had increment given. So they were happy. Right? Increment was given. So this is more like a natural phenomenon, especially at the initial stage. You can see they stay back. Right? And as the years goes by, you can see the overall data is more of a linear case. The natural right, phases are anyways there. You can see those natural phases, the iteration will be there, but here also it is more like a linear case, right? So this is with respect to increment being given, and we are marking that as 1. Now in the same screen, in the same right, AX, we are calling it as AX, right? So in the same screen, I will now try to take the data which is right, group which did not get increment. So I'll mark this and I'm calling this as label 0. And you will see there's a different color automatically assigned to it. 1 and 0. 1 is more linear. And people who are not receiving the increment, you can see, right? They're immediately jumping in the first year itself, they right resign. Second year, third year, right? A lot of iteration is there at the initial time. And again, you will see somewhere around 5 years and right Sixth year is fine. 7 years, you'll see that they did not get the entry. Second year also consecutively they did not get, so they resign. Right. So you can see that drastic decrease here is given here, which basically is telling us that more and more people will resign if the increment is not given. The same way we can do factor analysis. Here, the factor that we are talking about is increment. Now, the resignation could be because of various reasons, right? Like, what are the working hours? Whether working from home option is given or not, right? So on and so forth. I'm just giving some examples here. So for every factor, we can do this kind of a curves. Kaplan-Meier survival curves. And these curves will be able to help us interpret on how each of these factors is influencing the decision among the employees to resign. This is called as time to event analysis or survival analysis. This is Kaplan-Meier survival plot. Kaplan-Meier survival plot or survival curves. So this is a very, very interesting application. On top of the predictions, we will also do duration analysis. Prediction models will only tell us whether the event will occur or not. But when will it occur? This cannot be told by the simple prediction models that we discussed, right? So here we need right, duration analysis. All right, so this is about survival analysis application in HR domain, friends. This will definitely help understanding the factors which are influencing the employees to resign, and probably if that is the phenomenon for majority of the employees, we can also try and ensure that some kind of a policy is defined to address that issue that majority of the employees are facing. And the entire culture can also be changed for the organization to ensure that the iteration is controlled. This in turn will help the organization from cost savings perspectives, the production perspective, right, and the brand value perspective also. The continuity is very important for any brand to survive, right? So there you go, survival analysis helping the employee or the organization, or you can say HR people to manage the workforce in an appropriate. All right, so we will conclude the session for this for today, for the evening. I hope you have enjoyed the application of one very interesting analysis called survival analytics in HR domain. We'll try connect tomorrow. Hope to see you all tomorrow. Until then, take care and good evening, friends. Thank you.